So, quick review of the rules for sig figs from yesterday. You don't need to write these down again, obviously, but you can go and get your notes out for the next part of it. So, the first rule is that non-zero digits are always significant. Second rule is that zeros between non-zero digits are also significant. Third rule is that zeros in front of non-zero digits are not. So leading zeros are not significant. Fourth rule, zeros both at the end of a number and to the right of a decimal point are significant. So when you have a decimal point there. Rule 5, zeros at the end of a number with no decimal point are not significant. And rule number 6, zeros at the end of a number with a decimal point are significant. Any questions on those 6 rules? Okay, we're back out of that one. We're going to go into today's notes. Okay, so you don't have to write this one down, but we're going to talk about this one. You'll write the next one down. But significant figures of a volume measurement. So your scale equals 1 milliliter in this case. So the first and last digit is 8 here. So a good reading, if you're looking, whenever you're looking at a graduated cylinder like up on the board, you're going to want to get at the same level as the bottom of the meniscus, and that's where the water dips down. Can you see it on the board, how it curves? The bottom is the highest level that you're going to measure. So in this case, a really good reading for significant figures to try to be as certain as possible would be 8.2. And the second digit is estimated. So the estimated part of this measurement is well within the tolerance of the cylinder, which is estimated to be plus or minus 0.5 milliliters based on the scale. All right, continuation of significant figures or sig figs. Precision is the smallest amount possible, or the smallest possible unit that could be measured on an instrument. So how far can we take our measurement out to be certain? When we talked about precision the other day, he said it's as close as we can get each time. So we want our measurements to be as close to each other as possible. So then significant figures or sig figs are the numbers that result from a measurement. So when you figure out the smallest possible unit that you can get, that tells you how many sig figs should be in your answer. Sig figs in a measurement include all the digits that can be known accurately, plus a last digit that must be estimated. When a measurement is converted, we need to make sure we know which figures are significant and keep only those that are significant in the conversion. Anybody need more time? Okay, all figures that are measured are significant. Okay, the last one says to see handout for rules. I have it back here, but the copier is malfunctioning, so I'm going to post it in Google Classroom for you today, and then I'll give actual ones to you Monday for your binder. But they're the same rules that we went over yesterday, just in more detail. so that you can have them. Okay, so what is the length of this bar? Can anybody see up there?
Centimeters.
3.2 what?
Centimeters.
No, but 3 can, so it's everything that you know plus one that you estimate. So is it like halfway between the 2 and the 3? Is it almost there? Like, so like maybe like 3.23? Because remember it said it's everything that you know plus an estimation. So it's not quite 3.25. So we'll say maybe 3.23, like you all said. Okay? So those are the amount of, that's how far you can measure to the best of your ability. Now, someone else might have said like 3.22. The last one is an estimation. So then how many significant figures are in your measurement? Yes, 3. All of them are significant. 3 total sig figs. No, you don't have to write all of that down. But if that example is a good one for you to help you remember, you could write part of it down. I'll give you time to do that. So if we know the significant figures, we can know the precision of the instrument on our original measurement. Any questions about this one? Anybody want more time that's drawing it out or something? Okay. So now we need to talk about multiplication and division in significant figures. In calculations involving multiplication and division, the answer to the calculation must contain no more significant digits than the measurement with the least number of significant digits. Okay, so if you look at the example on the board, 3.23 times 6.1, how many significant digits are in 3.23? 3. How many are in 6.1? 2. So if we're multiplying those together, what's the most significant, most digits I can have in my answer? How many significant digits? Okay, it says you can only have no more digits than the measurement with the least number of significant digits. So what's the least number of significant digits on the board? 2. So if you have a calculator, I'll do it as well. 3.23 times 6.1 is what in our calculator?
Let me do it.
Okay.
19.7.
Okay. Okay, we have 19.703, but we can only have 2 significant digits. So we have to round 19 up to what? 20 points. Because if we don't put the decimal point there, is the 0 significant? No. So you have to put the decimal point there, but you can't put one after it, because if you put one after it, there's 3 significant digits there.
How many can you have? 2?
You can only have 2. Because 6.1 only has 2. So you have to round, and that's the closest measurement that you can get. The number that is the lowest. So I'm going to give you, we're going to do, no, we're not done with those. We're going to do 2 more practice of those. It's on the back of this paper. Don't be scared, I'm not eating. Okay, so if you flip over this worksheet to the back, hi please. It has the directions, again, for multiplying and dividing for you as a reminder. But the first one there, it says when multiplying or dividing, look at the measurements, and the answer can only have the number of significant figures of the least significant figure. So you have 5.00 times 2.0. What is the least number of significant figures in either of those? 2. So what is 5 times 2? 10. So you have to put the decimal point at the end. So you have to put 10 decimal. Do not add a 0 because then you have too many significant figures. Okay. All right. So then the next one is 360.00 divided by 9. So what is the most number of digits that you can have? 1, because 9 only has 1 significant digit. So if it's 360 divided by 9, our answer is 40. So if you just put 40 by itself, how many significant digits does that have? It just has 1, because there's no decimal point. So it's a correct answer. It is only going to get harder from here, Meg. But I believe in you.
I know, believe in myself.
You're going to have to.
Prayers, please. It's just so confusing.
Any questions on that one? That wasn't a question, but that works.
No, that wasn't really. I was not really.
I know. Okay, a couple more examples for you. So, 0.0053 centimeters times 285 centimeters equals 1.5105 centimeters squared. However, how many significant figures does 0.0053 have in it? No? Do leading zeros count? So it's 2. 0.53 has two significant digits. 285 has 3. So what is the most number of digits we can have? You can only have the least.
Oh, 2.
2.
Goodness.
So the measurement with the least number of significant digits is 0.0053. There are 2 there. Therefore, the answer must be rounded to have 2 significant digits. So the answer rounded to the correct number of significant digits is 1.5 centimeters squared. Please write this example down because we're struggling with it. So we need to make sure we understand the rules. So what do you have to figure out first when you're doing these?
What's the least amount of digits?
What's the least amount of digits in the two factors in the example or in the problem? Whatever the least amount is, that's as many as you can have in your answer.
I'm still writing this.
I'm not moving on yet. I still see plenty of pencils and fingers moving. Anybody need more time? Okay, on the next one, you can choose to write this one down or not. It's just division, but it has the same rules. So 8.654 has how many significant figures? 4. They're all non-zeros. Mag, you might want to pull out those sig fig rules, but at least you're guessing. How many does 10.0 have? 3. So how many sig figs can our answer have? 3. So 0.8654, whoops. We round that to 8.865 because 4 isn't 5 or bigger, so we just drop the 4. So again, you don't have to write this one down, you can. If you need to pull out that sheet from yesterday that has the rules on it, you are welcome to do so. Okay. Addition and subtraction. Different rules. Lots and lots of rules. So in calculations involving addition and subtraction, the answer to the calculation can have no more digits to the right of the decimal point than there are contained in the measurement with the least number of digits to the right of the decimal point. So are we concerned at all with the digits to the left of the decimal point? No. We're only looking at the right to the right of the decimal point in addition and subtraction. Okay. In this example, 25.46 centimeters plus 5 centimeters plus 256 centimeters. Which one has the least number of digits to the right of the decimal point? 256. There aren't any, right? So if our answer is 286.46, what do we have to round it to? 286. Why does that say, oh, it can't have any more than 256? So it can't be any more accurate than 256. So we have to round to 286. If you understand all that, you don't have to write like the bottom sentences word for word. But if you need that to help you, please write it down. Okay, subtraction example. 356.520 millimeters minus 256.11 millimeters. Which one has less digits after the decimal point? 256.11. It only has how many after the decimal point? It only has 2 after the decimal point. So 100.410 is going to have to become what? 100.41. Whoops. Again, you can write that down if you want to. If you got it, you don't have to write down the second example. So go back over to your paper really quick on the back where it has the adding and subtracting. So it says when adding or subtracting, look at the digits to the right of the decimal. Quiet, please. Your answer can only have the significant figures to the right of the decimal of the measurement of the least amount of significant figures to the right of the decimal. So if you have 5.00 minus 2.0, which one has less to the right? 2.0. So we have to have 3 point what? 3.0. And then the next one, 360 plus 9. Which one has fewer to the right of the decimal point? 9. There aren't any, correct? So what is 360 minus 9? I'm sorry, plus 9. 369. Do you have any numbers? Do you have a decimal point?
No.
No. And you don't have any numbers after it. Just 369. Any questions about those two? Okay. So the rest of the paper, keep it for Monday. We are going to start with this paper on Monday. When you come in, I'll have on the board that I want you to use your notes and try the practice problems.